This is where the better teams and lower teams can be separated on scoring, and then the following 2 minutes is the tablet up period, so the driver can control the robot while the humans can give artifacts
We
and
muted.
we can hear me right now. So for the teleout mode, it's 2 minutes, and the driver can. So in this time, driver can control the robot while human can give artifacts and to the robot, and then it is very important to have the pace when the driver is controlling a robot. And then for the team structures, each team had around 15 players, and then these followings are the team structure, like the small task teams that each team might have. So it's basically programming, building, CAD team, outreach, scouting, marketing, and drive team. And then for scoring, the scoring method is different for every year. So this is the year before last year, which we have to stack pixels on the backboard, and then this is last year's. So this is called Into the Deep. So we need to either put the blocks into the higher or lower uh, buckets, or we can push the blocks to the human area, and then the human can add a hook onto the block, and then the block can be hooked onto the higher or lower rod the on the field. And then this is this year is called decode. So basically, uh, there the there are artifacts or just balls on the field, and then the robot needs to pick up balls and then score into either the red alliance goal or the blue on the alliance goal. And then there's a certain motif which shows by these apotex, and it's random for every game. Matching the motif, which is the certain ball color pattern, can get extra points. So programming is a very important part of robotics. And then for FTC teams, the main language we use is Java. And then for common programming concepts, uh, there are like a bunch like odometry, aprotag vision detection, which help with launching and targeting. We can also have like road runners and field centric mechanism control. And then these are all basic like function like h- these helps to detect objects, to move to target, to score, and to park. For building, we can we get basically our metal pieces, our metal components from the Vex Robotics, Rev Robotics, and Go Builder. But we also use CAD since CAD is more flexible, and then we can have more of our creativity on the components we CAD, and we can 3D print it afterwards. So this is the chassis we use this year. This is the intake that we can intake these artifacts, the balls, into the robot, and then this is a spinexer. So to match the motif, we can spin the spinexer to the certain slot that have the correct uh, artifact, and we can launch that artifact to get more points. And this is a lounger. To so this basically all the components build up to a whole system that uh, help us score. And this is the control system we use. Starting from the camera, this year we use a limelight, which is pretty advanced, and we can detect balls and also our the April tag, which help with our aiming during the match. This is an expansion hub, so we can have a control hub on one side and an expansion hub on the other side, and we can have more ports on expansion hubs. For sensors, this year we use there are many sensors like color sensor, magnetic magnetics, switch sensors, and like distance sensors. This year we use color sensors so we can detect the artifact color to help with matching a score within the motif. For powering, we have motors and servos. For servos, we use servos for uh, like there's a shooter arm below the lounger, and it also goes below the spedexer, basically right here, so that the shooter arm powered by a sensor can lift the ball to the lounger. And then for motors, we use motors a lot. So the back two motors on the launcher and the four motors in the chassis for moving and strafing, and then there's also one motor for the roller on the intake.
So we are Team 2160, the Argonauts. So I know Bill was talking a lot about the general FTC, but I'd like to dive deeper into specifically our team. We are based out of Rutgers Preparatory School, that is in Somerset, New Jersey. That also means that we start with the school year and we end before the end of the school year. So this limits us in some ways that most teams do start before the school year starts. So it's just something we've run into. Um, we have the maximum amount of members, which is 15. We split everybody into task teams, as was mentioned before, and we try to have our older members mentor our younger members. And so we try to build this ecosystem where we have everybody uh, more involved with robotics. So this is just a picture of our last year robot, or the two. So last year we had to take these objects and bring them to a human player who attached clips to them, and then attach them to a bar. That was the main goal for a robot. So you could see a rotating arm, and you could see how we had like a lift mechanism with two lift mechanisms on the side and a rotating arm in the middle. So as you can see, a lot of this robot is built from aluminum. That's the Scobilda system that is a standard that you can just utilize. It's kind of like Lego for robots, except with screws and nuts and all that mess. But it just allows you to play around with how things work and make them as nicely as possible. And so that is what we mostly use for our robots. This robot was built mostly with the Gobola system, with the exception of a couple of small parts that were 3D printed, like the claw, just because we found that they were so much easier to 3D print. But this robot also didn't utilize CAD that much, which we found that, especially for robotics, was a big downside. We should have been using it significantly more. And this robot obviously had small iterations, but didn't change that much throughout the season. So here's this year's robot. Now, this year's robot is quite different, not just because the game is different. We started this robot specifically straight from CAD. So we basically uh, ch- checked it all in CAD before actually building the proper robot. Now, we didn't model it fully, but we checked that everything worked, and this is a big improvement. So this is actually our second robot this year. So this robot allowed us to improve on our last year's robot, or on our last robot from this year, and just make sure that everything worked as we liked it to. So we found this iteration actually helps a lot, and making a big step that basically leads to a new robot instead of just minor changes for a significantly for a single robot. We also did utilize a lot more 3D printed parts. Our intake, our shooter, it's all 3D printed, although we did replace our intake with CNC machine parts. Now, we found that it is access to CNC a lot of the robot. It just is too much. You don't really need it. But some parts that we found that we just really needed to strengthen, it is worth it to CNC it. So that just means cut it out of aluminum with a computer controlled machining system. So instead of just 3D printing them, which takes plastic, melts it, and prints it layer by layer. So we actually got the design award this year for making a robot with creative, unique, and functional design, which we managed to do with our unique spindexer, which was actually at an angle to solve a problem that you had to intake the balls low, but you wanted to fit some stuff under the spindexer, so you had to raise it up. So not many other teams did this that earned this the design award for unique design, and I think that overall, like we have found a lot of interesting and new solutions this year that have helped us a lot. Thank you for listening to our presentation.
Thank you for listening. Have a good afternoon.
Yeah, sure.
Okay.